Okay, so we're looking at tree diagrams, and this is going to progress from where we left off the last time. It says that tree diagrams are used to solve problems involving both dependent and independent events. Okay, so this is what we're looking at now. The following situation can be represented by a tree diagram. So Peter's got 10 coloured cubes in a bag. 3 of the cubes are red and 7 are blue, so it's not even. He removes a cube at random from the bag and notes the colour, and he replaces it. So now we're replacing, okay? He then chooses a second cube at random, record the information in the tree diagram. So we know he does this twice, and we're going to have 2 lots of trees. Watch how it works. So our first choice is there, and what are our choices? We've got red and we've got blue, okay? But remember we said they weren't even. We'll get onto that. Let me just move this here. Okay, now out of the 10, so there's 10 coloured cubes, so the 10 will be our denominator. 3 of the cubes were red, so the red only stands for 3 out of 10, okay? And obviously the blue is then going to stand for the 7 out of 10. You must always make sure that that 7 and that 3 add up together to get one whole, so it'll add up to give you 10, okay? So 3 and 7 will give you 10, which means if we added those two together, we'd get a whole, which would be all the cubes in the bag. So 3 of them are red, 7 of them are blue. Then our second choice we throw, and we know that we're going to put red and blue there, and we're going to put red and blue there. Red, blue. And again, that's going to be 3 out of 10 red. How many of the blue will be 7 out of 10? How many of the red will be 3 out of 10 and 7 out of 10? So that doesn't change. There's always going to be 3 balls out of 10 that were red and 7, cubes out of the bag that were blue. Okay, now this is where it comes. So that's the first part that's different. Now we have a look. Well, red and red, we then say our red and our red is 3/10 multiplied by 3/10, and we go 3 times 3 gives us 9, 10 times 10 gives us 100. So our answer over there is 9 over 100. Then we do the next one, which is red-blue, so that's going to be 3/10 times by 7/10. So that's going to go 3 times 7 is 21, 10 times 10 is 100. Okay, so we do our next one, which is blue-red, and we go 7 times 3 is 21, and our last one, we go 7 times 7 is 49. And I want you to show this working out here, okay? So therefore, we can then start asking questions about the probabilities of the story. I want to show you another one. So Rebecca has 9 coloured beads in a bag. So we know our denominator is going to be 9. 4 of the beads are black. So that would be 4 over 9, and the rest are green. What's left after 4 over 9? We've got 5 over 9. She removes a bead at random from the bag and notes the colour and then replaces it. She chooses a second bead, so we know it's going to have 2. The first question says, draw a tree diagram showing all the possible outcomes. Right, here we go. And it's done. I wish it was that easy. So we said our first choice was 4 over 9, and we said the black. Okay, so the black was 4 over 9, and the green was 5 over 9. Okay, remember adding those together will give us 1. Then we went black, green, black, green. We know that the black represents 4 over 9, the green represents 5 over 9, and then we times them together. So we've got 16 over 81, 20 over 81, 20 over 81, and 25 over 81. So we've done A, drawing the tree diagram. B says calculate the probability that Rebecca chooses first 2 green beads. So if she chooses 2 green beads, that's black and black, that's black and green, that's green and black, and that's green and green. So this would be the one here. So in this column here is where I want you to be putting BB, BG. You know how you normally do that. You don't have to write it out with the whole word. You can put an abbreviation. So you would look for GG, and you would know that that was the answer. So your answer then would be 25 over 81. A black followed by a green, so that's black, 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 green. So it looks like this one will be 20 over 81. Obviously, if it included 2 of these, you would add them together. Okay, you would add that fraction to that fraction if it happened to be 2 of them. Just want to show you something slightly different. So Peter tosses 2 coins, draw a tree diagram for the possible outcomes. Use your tree diagram to find the probability of getting two heads, a head, a tail, in any order. Okay, so what I want you to do here, he tossed the coin twice. We know that we've got half and we've got H, head, tail. You guys would know two heads straight away, head and head. We would know that it would be a quarter, a head or a tail in any order. So that would be a head and a tail or a head. So it would be those two, which would give you a quarter and a quarter. And if you add a quarter and a quarter together, you're going to get half. Okay, so that would give you the head and the tail. The other one I wanted to show